Hello and welcome to another video. In this video we're going to be working on palindromic substrings. And in this problem you're given a string S and you want to return the number of palindromic substrings in it. And a string is a palindrome when it reads the same forward and backward. A substring is a contiguous sequence of characters within a string. So for example, when we have ABC, the only palindromes in this word are the letters A, B, and C, so we have 3. And in AAA, we have the letters themselves, and then we also want to count these. So even though you do have like the same, they don't have to be unique. So this would be a palindrome, this would be a palindrome, and this would be a palindrome. So we have 6 total. And essentially there's a few ways of doing this, but the best way to do this, like number of palindromes or longest palindrome or whatever, is building from the center. And so let's just kind of go over how that would work. So let's just have some kind of string. Like we'll have B, A, B, A, B, 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 A, B, or something, right? Something like this. And essentially what you're going to want to do is, palindromes can be 2 kinds of palindromes, right? Odd or even. And the way building from the center works is, for an odd palindrome, you want to start, so for both of these you're going to have a left and right pointer to like the bounds of the word. For an odd, you want them to start at the same place, so like here, and then you build out. So like you would go, like let's say, or this letter, you would build out 2 letters at a time. So you'd add 2 letters, 2 letters, 2 letters, 2 letters, 2 letters, and so on. And then for even, you want to start at 2 letters next to each other and then build out that way. So then you maintain an even number. And essentially the way it's going to work is we can just simply build out, and as we're building out, we can just check the 2 characters we're on. And if they are equal, we can keep building. So for a word like a race car, let's say, that is a palindrome, if you started at E, this is an odd palindrome, you'd say like, okay, well, E is obviously equal to E, but let's build out. So if we build out, these 2 are equal, so this is still a palindrome. These 2 are equal, so it's still a palindrome, and these 2 are equal, so the whole thing is a palindrome. So the way it works is you can just build out from the center, and then as long as the characters are equal, that whole word is a palindrome. And then every time the characters are equal, you get a new word, right? So for example, let's actually go back to race car. Let's figure out like how many palindromes there are. So this is 1, then we have 2, 3, and 4. And so race car would have 4, right? So every time you build out one, you're essentially creating a new word, and you just check like, is that equal? And if it is, let's keep trying. And if not, we'll just return. So we're essentially just we're just maintaining a count of how many words we have. So let's kind of go through this this word as an example, and let's show our output. So what we're going to do is we are going to maintain like a result, and we are going to have a left and a right pointer, and I'm just going to represent those with like a line. So like if they're both on the same, the left and the right are both on the same letter, and if they're over here, then the left and right will be on these 2 letters. So we're going to start at letter B, and obviously B is a palindrome, but can we build out? No, we cannot, because we'd be out of bounds. So we only have 1 word here. So we'll add 1. Now we go to letter A, so this is a palindrome, so that's 1. Then we build out. This is also fine, right? So that's 2. So we have 2 there. Now, also we have to consider the even palindrome, and for even palindromes, we're gonna have to get every 2 letters that are next to each other. So we'd consider this. Is this a palindrome? No, it's not, because the letters are different. So now we go here. And I'm just gonna like write down every single number, and then we'll add them late at the end, right? So we have 1 for B, we have 2 for A. Now we're over here, so we have 1 here. Now let's try to build out. This is valid as well, so we have 2. This is valid as well, so we have 3, and then we'd be out of bounds if we try to build out. So we have 3 there, and we do have to consider the letters next to each other. So is this a palindrome? No, it's not. So now we'd go to A. So we have 1 here, 2. And now we can't build out because these wouldn't be equal. A and B wouldn't be equal, so we have 2 there. Now for this AB, they're not equal, right? So this is not a palindrome. So now we'd go to this letter B, and we'd say, okay, B obviously palindrome. Is AB? No, so we'd only have 1 there. And now for this B, we compare to this A, and they are not equal, so you can't really build out there. So now we'd be over here. And this is a palindrome. We try to build out. This is a palindrome. So that's 2, 3, and then we can't build that anymore. So we have 3 there. And let's get rid of those. And now we can finally have an even palindrome, right? So we were at this letter, we'll just compare it to the letter before it. So the letter before it, and this is a palindrome now, and then we try to build out, and this is not. So we'd have 1 there. Now we are in this B, I believe. And if I miscount it, it doesn't really matter, just like as long as you understand the idea of it. So we're on this B, we can't build out anymore because these two are not the same, so that would be 1. Now we try the even one. So there's only 1 here, we can't build out. Now we're on this A, and you can't build out, so we just have 1 there. And then if we try the even one, that doesn't work either. Then we're on this A, and we can build out here, and we can build out here. So that's 3 total. And if we try the even one, that ends with this A, so this is fine, but you can't build out anymore, so we only have 1 here. Now we would try this A, and you can't build out, so we'd have 1 there. Then we would try the letters of A's that are next to each other, so this is fine, but you can't build out, so we have 1 there. And finally, our last one would be B, which you can't build out on, so that's 1, and then also this, which is another 1. So we would have 1 and 1, and we can add all these together, right? So we have 3, 7, 9, 12, 13, 14, 15, 16, 19, 20, 24. So somewhere around this. So, but essentially, let's write down our logic. So for every letter, check odd palindromes and even. For odd, make left and right both that letter and build out. And then for even, make left the letter before it or after, and right the letter and build out. And that's pretty much it. So you start at the center, and you start like, you know that every possible start location will either be a letter or between 2 letters, so then that way the left and the right, it'll be even. And you're pretty much doing that, so we can just have a recursive helper function, and then we just go through the word, we call that function twice, right? So like, in my case, I'm actually going to use the letter and the letter after it, but either way works. So, and I'm just going to initialize it to 1. You can do the letter before, so initially I'm going to say like, okay, well, we're going to start at this letter actually, because we know that like if we start at this letter, there's only 1 palindrome here because you can't build out. So we're going to have initialize it to 1. We're going to start at this letter, and then for every letter we will pass in the letter and the letter for odd, and then for even we will pass in the letter and the letter after it to check for evens. And so that's pretty much it, and this is the easiest way to do it, and that's going to be an n-squared function. So let's actually code it up now. So we are going to make a helper function, and it will take a left, which will be a number, and a right, which will be a number, and it will return a number. And we're going to have a result. And then we essentially just have a while loop of like, while these characters are in bounds and they are equal, let's keep adding. So we'll say while left is greater than or equal to 0, and right is less than s.length, and the characters are equal. So while these are all the case, let's add to the result, and let's build out. So essentially left minus minus and right plus plus, which is building out, and then finally we return the result. And so we have to do this, and we're, like I said, we're going to initialize our palindrome count to 1 because we want to compare every number to, I guess technically, honestly, I think this, yeah, I don't think we even need to initialize it to 1 because this is, because in JavaScript, if you have an index out of bounds, it'll just return undefined. So this would actually be fine. Would it be fine? Yeah, I think so. I think it'll be totally fine, but we'll test it. So I don't even think you need to start the second number. So essentially you can start the first number, and if you put in like 0 and -1, then this just won't be true, so you'll return 0. So you don't even need to do that. So now we can just say for let I equal 0, and similarly, if we are out of bounds the other way, it's also going to be fine. I is less than s.length, I plus plus, So we have to call this function with even and odd. So we'll say pals plus equals counter II. This will be the odd version where the left and the right are the same letter. And like I said, you can either do the letter and the letter after, or the letter and the letter before. We can actually even do the letter before. Might as well, right? So essentially, we'll take every letter and the letter before, and on index 0, this will be -1. So this will just not run at all, which will be fine because it'll just return 0. So that should still be fine. And now we can return our number of palindromes, and we should be good. So let's take a look. Okay, and let's see. And there we go, and it's pretty efficient. So let's talk about the time and space for this one. So for the time, essentially what you're doing is you're starting at every single letter, right, in this in this for loop, and you are calling this counter function. So this counter function builds out, so this could be worst case O of n, and you do have this for loop, so this is n squared, because you're starting at every single location and trying to build out. And for the space, we just have like pointers. We're not maintaining a string or anything. So that's going to be O1. And yeah, that's going to be all for this problem. So hopefully you liked it. And it's definitely a good way to build palindromes. And I think there are a few of these palindrome problems. I think the one I did yesterday in Python was also very similar to this. So kind of, if you haven't seen it before, kind of hard to come up with. But once you see it and you do see palindrome problems in the future, definitely something to consider. I think this is a lot cleaner than doing like DP or something. And yeah, hopefully you liked this one. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.